Perfect. Well, thanks everyone. I'm really excited that Daniel's joining us today. Tofu.
Be the youngest member.
It's true. Yes. Yeah, he gets out of work. We'll have to get him some stickers.
Absolutely. And the socks.
Okay, it's true. We still do need to order some socks. They'd be much cuter on him than the rest of us, though. So we might prioritize that. Cool. Yeah. Well, let's maybe start with quick reports from folks. I can give a quick update on Colorado and such. But yeah, let's go around the room. Who would like to start?
Lead us off, Lindsay.
Vahid. Go for it.
Nobody? I guess I can go.
Nothing new, actually. I'm just recovering myself after the first.
Fair enough.
You know, while you're doing what I'm about to, like, still writing 2 papers at the same time.
Yeah, it's looking really solid. I've got half my notes plugged in, but there's another half I'll try and get to later today, and also get you a section on the combo objective function stuff.
Nice, thanks.
And then yeah, I mean I'm ready to merge my PR, but I've got one check failing, and so I had it passing Travis. I was given some reviews that was really just change a couple variable names. It's pull request 824. Basic website refactor, yeah. And so, yeah, your changes were some suggestions on changing a couple sentences and changing some variable names and something about formatting the strings for some of the plots. And so I did that, and the test fails. It builds properly, but I think one of the things I did was I deleted the auto-generated stuff from Sphinx Gallery for the examples. And I'm wondering if, because I did that, it sees it as a change or something Travis has to recheck, and now one of those examples is failing. So I'm not, you know, the changes that I made does not feel like something that would have caused an error or caused something to fail. It does fail the docs test now, and I'm just having trouble finding what that error is. So I think I've run into similar situations before.
Yeah, thanks, Devin. This one was a weird, I'm sorry I haven't had a chance to actually ping you on this. I just sort of started playing around with it this morning. It looks like it was just an issue with the version of Sphinx. So I actually, as you were speaking, created a pull request 829, which at least the push passes. So the PR should pass, and that should hopefully fix all of these. So I will try and get that merged in ASAP, and then we'll check your branch and go from there. Because that's an awesome set of tutorials that you've put together, and that's gonna be really useful. There's more people using SimPEG than I realized, which I will tell you all about afterwards.
Okay, no, that's good. That was another thing I was thinking, is that maybe it was either passing locally and that it wasn't using the version of Sphinx on Travis was not the version of Sphinx that I was building it on. That's something that I guess I could check as well. It would be in the requirements then, requirements dev. Yeah,
it's in the dev requirements, but I've got that. So I just dropped a link for the pull request 829 in the notes. And so as long as that passes, then there's nothing that you should need to do. So we'll get that in, and then I'll merge that into your pull request. And then as long as that all passes, then we'll get it in.
Yeah, that sounds great. And then I can spend time working on the utilities refactor, which I think is going to be a big undertaking. But maybe I'll put more time towards that too.
Let's chat. I'll put that actually on the longer discussion items, because there's a couple things just to chat about strategies for that, especially given we have a lot more users that are not vocal than I realized. And that sort of came to light when I was in Colorado, which is super cool. But it also means we need to be very intentional and thoughtful about how we do this refactor.
Yeah, no, I agree. Any like additional collaboration, I think it's actually very, very important.
Excellent. Thanks, Evan. Mike, I think you're the next one around the table.
Just writing and editing.
Excellent.
We're getting there though. We're getting there.
Excellent. Congrats. And Don?
I'm working more on the Quest data set, VTEM and Grav and Mag. I'm just in the middle of it. I don't have much to show, but yeah, working on it. And I guess Nick pushed a lot to my to our common script, our inversion script. We should put Nick in as contributor. Eh? We keep forgetting this guy, but he's actually contributing a lot.
That's a really good point. Feel free actually to start, if you want, just a quick pull request on the authors on SimPEG. There's an authors.rst, and you're welcome to add him there. And then that will also hopefully serve as a bit of a refresher for us when we create like the pictures of folks using SimPEG to make sure we include him.
Perfect. Yeah, I'll do that.
Awesome.
Don, I want to add something.
Okay. 1 second. We have more.
I just forgot to correct something. I have already a program, a script for computing the power spectral density of potential field datasets, 2D and 1D. I sent the script to Dom. I don't know how can we add it to the rules of the SimPEG. It's very important. It's very useful. Actually, tools in potential fields in gravity and magnetic is PSD, and it can be added by Dom to the scripts in SimPEG to use in future for interpreting the gravity or mag data. Can be very helpful.
Sounds good.
Excellent. Cool.
Perfect. You guys.
Excellent. Sagi and Daniel, do you have any?
Nothing really particular, but we had a meeting in Stanford for our groups. Like it's like a consortium meeting, but kind of the audience is a little bit different. It's more like local agencies and water agencies. But there was a little bit more kind of positive conversation about kind of like in a state level using some open source to show, let's say, how airborne EM works. So I'm like, it's just a seed at the moment, but I think yeah, we can actually sneak in and use impact to show, okay, here's how airborne EM works, and kind of like the public interest is pretty high here. I think there's a lot of potential, and we have a connection in the water board. So yeah, and then it seems that the girl from the water board seems pretty enthusiastic using this open source software to show, okay, what it can do. So yeah, I haven't really started, but I think I'm gonna set up an email with her and then like make some progress later. But yeah, I think it'll be pretty exciting to show kind of SimPEG logo and that level and being useful. Right. Other than that, any update in these days?
That's awesome, Sagi.
Yeah. Hey, Sagi, I have a question for you. Have you ever inverted multiple stations for a one 1D model? Like it would be sort of a best fitting 1D model. Can you put multiple data for one mesh?
Yes. So I think if you look at one of our paper, the Ducks paper, latest Ducks paper, we did the joint inversion, exactly what you said. So we inverted Resolve, NanoTem, and one of the airborne platforms. So we actually inverted 3 different inductive source data to just for one model. So you could do that.
Okay, sounds good. Thanks.
Dom, I can drop the link. It's in the SimPEG research. SimPEG research repo?
Yeah, there should be a notebook, and yeah, so you can look at that joint inversion notebook.
Excellent, excellent.
Yeah. And you can also do that for the multiple sounding as well.
Well, yeah, that's the same thing, right? Just, yeah, I got it. Sweet. Thank you.
Yeah, and now it's in the notes.
Right. Anyway, so if you've got multiple airborne data set, technically you can invert all of them together. Well, in EM platform, not other data set.
Excellent. Doug, welcome back.
Am I back? I guess so. Let's see. So I've been traveling, but we're back now for a few days. And actually, the trip to Myanmar was actually really successful. So we've talked both at the people at the national level as well as at the state level. And to cut a long story short, basically the project that we were planning from the Geoscience Without Borders has now been elevated to a national project. And that'll give us a lot more visibility. It also greatly enhances our chance to make an impact. And I think maybe the one thing that is worthwhile saying here to this group is that I think right now is the perfect time for us to concentrate somehow on consolidating like all of the various pieces of information in whatever format they have for the DC resistivity problem. So we've got, the GPG, we've got EM GeoSci, we've got SimPEG examples. Sagi's been developing some 2D inversions. Lindsay's got some 1D inversions and forward modeling. This is an opportunity to kind of think how we might want to restructure some of that material so that it can, really make an impact kind of long term and for various places. Certainly, if we are successful in Myanmar, then the material that we develop will be extremely useful for any place else that somebody wants to go in and learn about DC resistivity and how to interpret the data and how to collect data and what the background is. So we've got a ton of stuff in various forms, but I think for all of us who are kind of involved somehow in the DC problem, it'd just be good to think for each of us, like, okay, what sort of material would we want to have at our fingertips, and then maybe collectively try to figure out how to refactor all that material and put it in a framework that is then really accessible and usable.
Yeah, we can, that might be worth teeing off some of that conversation today, actually, and then we can perhaps follow up and have maybe a smaller meeting in the next few days with folks who are directly connected with the project to come up with a bit of a game plan for like where stuff sits.
Yep, I think that would be great. Yeah, the thing that we're up against in Myanmar is that people there have a very low kind of background, both in the science, certainly in the computing aspect, and also in critically thinking and how to kind of go about really getting information from the data. So all of the resources that we can put together from the point of understanding, and importantly also from the point of view of collecting data and what to do with it, it'll be really well received because they want to do it, they need to do it. They have to drill deeper wells and they are expensive. So anything that can be done that shows successes in this regard will be really well received.
I guess I have a few thoughts on this. The first is, are you proposing, you're not proposing any kind of changes to the content of the GPG? Because as it stands right now, the purpose of that was to be a textbook for an undergraduate level introductory geophysics course. And the way that package has been sort of completed works very, very nicely at this point. If we start to, I guess, add things or take things away, that could lead to a lot of work for managing materials related to a course that works quite well now. As far as maybe adding content to EM GeoSci, I think there's some spaces and some things that are maybe not filled in. If I was going to add this kind of content, for me, that would be maybe for the GPG. So, or sorry, for EM GeoSci. That's sort of a platform for that. I thought that was kind of the purpose of that website, to be honest.
Well, it was. I'm not sure that it's actually structured as efficiently as it could be from the point of view of somebody just being able to, step in and do something. And at the same time, there's a number of examples that we need to perhaps do within SimPEG and some documentation. There's just a lot of things, I think, to be done. Yeah, I'm not suggesting that we go in and alter the GPG. The GPG has been developed for a purpose, and it's working. And there might be some things that come in that would be actually really useful to the GPG yet, or there might be links that could be used. Within the repackaging material, there's also possibilities for linking stuff up to the GPG. But I think it's a matter of just trying to collectively look at all of the things that we have, trying to estimate what we want to do, and then figure out how to kind of put everything together so that it's a little bit seamless from the point of view of the end user, and he can just use it to understand and also to process.
Yeah, well, I guess maybe one approach, if you remember sort of our meeting from yesterday, about turning, well, we had the ZTEP or the ZTEP and the MT, and we had this data, and the end result right now is a Google Doc that says, okay, I'm starting out with some data and topography, and ultimately I would like to invert or get a best interpretation. And we went through the thought process and the best practices for somebody who wanted to take MT data and get recover a conductivity model. And there might be, with what we do now, there might be space to have something like that on the SimPEG website, which would have kind of an extended or applied A to Z. That might be something that could be pretty useful, or that's one place that I would think of putting it once we get to actually having all of our coding set up for the simulation class.
I think that's a great suggestion, and I think that having things like A to Z are just so insightful, and especially if you can sort of also have that opportunity to get down and see the code in some cases. And so you can work with that either as somebody who's not necessarily really a coder, but is using codes, and also somebody who really wants to kind of get into the codes. If all of those is kind of in one sort of package that has a nice, easy flow to it, I think that could be really useful.
And Doug, do you have, I know that you and Ren were working on a bit of like a course outline. We also have everything from the disc, like the slides and that sort of ordering, because I think that EM GeoSci, ideally we restructure some of that to start looking more like the disc.
Mm-hmm.
Again, this is actually something that we need to make sure that we actually create like public announcements about. There's a lot of people using EM GeoSci at Colorado School of Mines very regularly. And so, which is super cool, but that also means that when we like change the links and break them all, we want to make sure that we've informed people sort of why we're doing this. And that's fine. And that's something that we can be thoughtful about when we merge pull requests and bump version numbers and things like that. Yeah, but if you've got a Google Doc going, then maybe what we can try and do is like parse some of that and say like this chunk fits GPG, this fits EM GeoSci, this should be a SimPEG example, and this perhaps is a standalone repository just for this specific project. Is that
yeah, that's got a kind of a right ring to things.
Okay.
Absolutely.
Anything else on that front, Doug?
No, I think not. It's just something that I kind of wanted to bring up now, both because of where we've just been, and also we're planning to go visit or do this project at the beginning of February, which, because of the December holidays, is going to come up extremely quickly. But the other thing that I think is also important here is that we're going to try to identify these trainers that we're going to develop. And they have acquired data, this is the national DRD, in various states. And they have inverted it in 1D and made some interpretation. So what I'd like to do is to start getting people in Myanmar kind of connected with these data and the use of our 1D codes to reinterpret the data and see how it matches what they had before, and to start generating some case histories. So in order to do that, right, we need to have kind of the resources in a format that they can easily go ahead and use at this point. And since some of these people will have no real background in a great many things, this will be a challenge to deciding what to present, what to show them at any particular time in their quest, and have something useful that they could get it done.
Okay, well, I'll give a couple updates on Colorado School Mines, and then just some other random things, and then we can circle back with whatever extra time we have and maybe dive a little bit into the utils discussion, spend a bit maybe on the groundwater project and DC resistivity, and then if anyone else has items, feel free to add that as I ramble along. So I just dropped 2 links in the notes. So the first one is was a single notebook that I've owed Kamini Singa for a while. So I finally got around to doing this. And so it's just a simple, we're running the 2D DC resistivity problem, basically unpacked some of what we have in the apps. Because she wants to be able to go in and edit the figures and things like that. And that's harder to do from the apps than it is if you just have access to the raw code. So if anyone's willing to just take a look, and feel free to add comments, or if there's things that you think could be helpful to add there, that would be great. And then if this is a useful set of examples, then maybe it's something that we can pull into the SimPEG docs at some point in time. Yeah, so feel free to take a look. And actually some of that might serve the GWB project. So worth checking out. Yeah, and then last week I was at, I was in Boulder and Golden. So I was in Colorado all week. Went to Boulder and I chatted with a couple people there. So I chatted with Leah Wasser. She is at CU Boulder, and she is the director of the Earth, I think it's called the Earth Lab, and they develop a bunch of educational resources for more geospatial analytics. They've actually developed a bunch of notebooks that ended up in software carpentry. And so, yeah, so that's actually worth just taking a look at, maybe for inspiration. They've done some really nice work. And then she's also the one leading the charge on Pi OpenSci. I'll drop a link in. So it is basically, in a sense, so, I mean, folks here have heard of JOS, right? Journal of Open Source Software.
We know the editor.
Okay, well, one of the editors, former editor. And so JOS, you can publish software, and the review is basically just a GitHub checklist. So you're reviewing for are there tests? Are there examples? Are the installation instructions clear? All that sort of stuff. PyOpenSci is a bit more, it's meant to be a bit more like mentorship and sort of hands-on to help folks get from like just starting an open source project to actually running something that like can scale and has decent documentation and those sorts of things. And so it's a cool project. And that is, yeah, what she is leading. I met with folks at NCAR, which is also in Boulder, in like the most beautiful location. You basically like drive up this long road right in front of the Flatirons in Boulder, and they like have this enormous building there, and it was pretty nice. So we were chatting a bit about, and this also came up with Leah, about best practices for open source software development. And I mean, we gave the workshop at AGU last year, and we'll be giving it again this year on sort of best practices in software development. So more than software carpentry, actually, like how do you design a package and run a package and things like that. And so what sort of came out of this is that I think there's going to try and be a bit of a concerted effort to consolidate some of these materials and actually start putting together guides and resources for software development, which is pretty cool. So I'll keep you guys all posted on that. There's nothing actionable at the moment, but it's cool that it is like a timely discussion. And I think there's things that we can sort of learn along the way there. Yeah. Then I went to Golden. I gave a presentation, so I just dropped the like Google Slides link in there too, if folks want to see that. Which was a fun presentation to give. And then I ended up chatting with quite a few students there. So they had me lined up for a lot of meetings, which was fun. And I was quite impressed how many people actually, basically, the meeting was they pulled up a notebook and like pointed to a line of code that was SimPEG and said, can you explain to me what is going on here? And so I was a bit taken aback by how many people were up and running with SimPEG and had like very specific targeted questions to try and understand what's going on. And so that made me think that like prioritizing getting a discourse page up and running, I think is important. Slack is great for sort of real-time communication, but in terms of like capturing questions and capturing content, it's pretty terrible at that. And so, yeah, so I will try and put some effort into getting some initial scaffolding around discourse, and then send the link out for feedback and ideas. And then once we have that in a state that we're happy with, I think we blast out an email, particularly to folks at Colorado School of Mines, and just say like, hey, this is meant to be a resource. You can come ask questions. It's a bit like effectively supplementing documentation, and questions that are asked on discourse where people can't find answers in the docs are then an indication of what extra stuff that we need to have in the docs. And through that too, there is a student, Andrea, who works with Yagua. She's going to be pushing on magnetotellurics. And so at some point I want to connect her with John, but she's really interested in doing anisotropy, full tensor anisotropy. And so there's actually nobody who's seriously looked at that with SimPEG. Most of it is plugged in, but none of us have really like actually hit on that. So I'm really excited to see that she's interested in getting up and running with that. And so that will require, this brings me to the point about utils, because she is going to be going in and playing around with some of the utils for MT. So she's someone that we need to keep in the loop on just where things are moving and where she can contribute. And then this also might lead to some things that we need to think through a little bit with mappings, because we haven't really used mappings with anisotropy. And so the expectation, like when you're sending an anisotropic model into the forward problem, is if we're doing a 3D forward problem, if the anisotropy is diagonal, then you send in an array that is width 3 by length number of cells. That's diagonal, so sigma x, sigma y, sigma z. If you have the full tensor, it's width 6, so you have the off-diagonal components. And so that's fine, but that means then like most of our mappings are expecting vectors always. And so we're gonna just have to put some thought into where it makes sense to allow wider arrays basically to be passed around. Because there's some places, I think in the XMAP, for example, we actually flatten whatever comes in. And we might not want to do that. Yeah, so that'll just take some thinking and sort of being in touch. But if you see her pinging and asking questions, that's sort of the context, just to keep in mind. Yeah, that's about it. Does anyone have questions on?
So Lindsay, like what kind of application were they kind of interested in Colorado School of Mines? Like so MT is a good example, but so there are a lot of people were bringing notebooks and asking about SimPEG. What were the sort of main application that they were sort of interested?
Yeah, so for Yagua's group, it's mostly mining and oil and gas applications. There was actually a master's student who I chatted with, and actually this is totally relevant to the GWB project, who's also doing 1D DC resistivity soundings for groundwater with Geoscientists Without Borders, but just in Africa rather than in Myanmar. And so they actually also need codes. And so I think that whatever we're developing for our project, we should absolutely keep her in the loop. Because ideally this serves both projects, and there could be a really cool story to tell afterwards, like with a leading edge article or something like that, talking a bit about open source software and how that can be a mechanism to serve multiple projects. So groundwater, I chatted with some people who are in glaciology, so they're not necessarily using SimPEG at the moment. We connected more so on potential developments with ICESat-2. So that's a satellite that's been launched. I think it's been running for about a year now. And it's basically LiDAR from space with green lasers, which is cool. Because green is tuned to reflects well off of ice. So it measures LiDAR around the world, but it's specifically tuned to do well with ice. And so, yeah, so we chatted a bit about that. Yeah, so there's quite a range of applications there.
Lindsay, you'd mentioned that there was quite a few people actually using EM GeoSci.
Mm-hmm.
So in sort of what regards and how have they been using it, and also beefs or bouquets about the usage of it?
So for the most part, people have been actually just like very excited that this material is online. When I like point out that I think the organization is challenging to sort through, they like acknowledge that, but it didn't actually seem to be a huge blocker, which is cool.
Oh.
And so for a lot of the use that I saw, it was in a sense like the fact that we have derivations and things like that in there and discussion around that. It seems like that's been quite helpful. So like Andrea, for example, had written some 1D analytic codes sort of based on what we had, what we've written up for the n-layered Earth. And she then basically used that as a starting point to work through the anisotropic version. Which is cool. So
that's good. That's the first feedback actually that we've had about somebody actually using some of that.
Yeah, so people use it. Yeah, and I was amazed at how many people were using SimPEG who were not necessarily in touch with us, and the fact that they were able to get up and running. And a lot of people did complain about the fact that we don't have enough sort of user documentation and things like that, but they were very excited to hear that Devin is championing that and that it is coming in the pipeline. And I think Discourse will help with some of that too.
So did you tell him that Devin was going to have everything done within the next 3 months?
Absolutely.
Thank you. No comment from you, Devin?
I'm just crying on the inside, but no. I'm excited. I'll see what I can do.
Yeah.
I will give him some.
He's got an energy
Yeah, it's
drink
not
right
strong
here.
enough. I need the Red Bull now.
Oh wow, yeah.
Well, I hope that that's exciting, because it really does mean that like your work is having huge impact, which is super cool.
Yeah, I guess I'm definitely excited about it, and it means I'm gonna crack the whip on what's being developed in the simulation branches. I don't know if now's the time to talk about it. I was hoping if there was ever, is there kind of like a place where we're going to hit with development of the DC stuff and the potential field stuff, where we go, okay, we've accomplished this list of things, let's bring it into the base simulation branch. I guess I was wondering if I mean, you guys are the ones who are working on it. I'm wondering if there is actually a set of very explicit targets for what tasks need to be accomplished before that gets unveiled or finalized.
That's a good point, Devin, and perhaps maybe like Dom, John, and Sagi, as you guys are pushing on stuff, like if we can even have sort of a checklist just in the pull request of like, here's the scope of this thing, so that we know when to stop, I guess. I don't know, Dom, do you have comments on where you feel things are at?
It's never gonna end. I mean, I don't know. It's a part-time job, you know. We pitch in whenever we can, whenever we have time. But it's hard to tell. We're gonna be done in 6 months if we not. Yeah, I don't know. I have no idea.
That's fair. But are there? I think to Devin's point, just like if we can set some explicit goals, like yes, it'll never. I mean, there's lots that we can continue to do, but it also. It doesn't, we don't have to have like everything parallelized and everything, like, we don't have to have the entire sort of wish list accomplished before we say that, you know, the simulation class has been plugged in, it's running, the APIs match, good enough, we will keep pushing forward after that.
Yeah, I guess that's sort of exactly my point is, there's all sorts of awesome stuff that's getting developed, but then are we gonna make it so we can't run a basic gravity forward modeling because we really want to get to parallelizing a particular problem? Like we're keeping, I know I have a feeling that we're keeping some of these tools that are fairly straightforward from people because it's part of a branch where there's continuous development. But we have a whole bunch of stuff that actually works that could be used right away. So I don't know, I just feel like it's something we should bring up, and just if we have an explicit set of tasks, then you finish a checklist and then you go, okay, let's bring it in, because yeah, it could go on forever.
Yeah, that's an important point, Devin. In terms of like the simulation branch itself, and maybe this is also a way to square some of this, Dom, is if we get, I can take a look at where that's at. It's been a while since I've had time to touch that, but I can try and spend some time this week looking at basically, have we ported the API? And I think that's, to Devin's point, I think that's a good checkpoint, is like if everything is now on the simulation class, we'll merge that branch in, and then you can keep pushing forward on the Dask parallel side, and we can try and parse that into pull requests as pieces become ready. Do you think that makes sense, Tom?
Well, not really, because it's so invasive when we start doing this that there's no point. Like people can already run versions, like they have V0, like, you know, I don't know. I don't see it requires time. I don't have time to like do this right now. I mean, it will happen at some point. That's the best answer I can say right now. If someone wants to do it, they're welcome to do it.
Do you have a sense of like where it's at and what things need to be done? Because I think that's that's what's challenging here is we don't necessarily have a sense of like most of the roadmap right now, and this is also my fault in the simulation branch, is like in our heads. And so kind of like figuring out what check marks we've hit or not is actually a challenging thing to do.
Can we just create a set of projects, one for each branch in GitHub, and then say what the remaining tasks are?
Yeah, that's good.
And then, you know, I definitely get, it gets done when it gets done, because you can't just put some kind of, it's going to take 3 weeks or it's going to take a month and a half. But it is nice to kind of know that when you check all the boxes of the stuff you want to accomplish, that you go, okay, I'm at a point where I can bring stuff in and new stuff can be done on a separate branch. But maybe just even writing down what our list is, or our wish list for what we want to accomplish in that particular PR would be beneficial to start. And I guess I have a little bit of a wish list, probably even more basic than what you guys are working on, which is really just with all the new simulation stuff, I would like to be able to run a forward modeling example for gravity, magnetic, maybe gradiometry example of those, DCIP, FEM, just be able to do that stuff as one set of tasks that I think is a pretty good benchmark for being able to add new things to people.
Yeah, let's divvy it up.
Yeah.
Let's set up
Okay.
tasks. Good.
That sounds great. And do you need any? I think anybody should be able to create GitHub projects. If you run into any walls with that, just ping me and I will give you permissions to do whatever you need to do. Just let me know what you need.
Okay.
Excellent. Cool. Yeah, and I think and actually, Devin, this might even be a good place to start, is planning out the utils refactor. That gives us a fairly concrete thing of something that hasn't been done. But that's something that I'm happy to jump in and like help provide a little bit of guidance just as to like sort of order of operations. And Dom, I'm sure has some ideas there too. So that might be a good place to like test out creating a project, and then we can start doing that, because the simulation one is going to be a bit more challenging and require some conversations. So if you get sort of like the infrastructure in place for something that's a little easier, that might be a nice way to go.
Yeah, and I think we talked about that a week or two ago, and Dom gave me a couple good strategies for how to start attacking it. I have to revisit it.
Yeah, and so this is a way to revisit and just write that down so that it's clear to everyone what's changing.
Yeah, well, it sounded like the first thing was almost start on the master branch. Look at all of the look at how the utilities are being called in the current class structure, and once that's being called correctly, then I think we can change stuff in the I guess the utils folder. There was sort of a way to basically make sure that the class, all of the classes in SimPEG right now are
Oh, I think you froze.
utils in kind of the correct way, and then we could move them where we wanted them. So that you could basically just say from utils call make vect, and it could live somewhere down the line in that parent directory, but that it could just be called, say, from utils give me this. I think that was sort of the idea. Did I get that right, Dom?
Yeah, so at this point, I would actually say start from the simulation branch. Don't worry about starting from master.
Okay.
Yeah, I think that'll be a bit simpler. But yeah, and then if you write those steps down, then we can help flesh that out in a little bit more detail, just so that it's like becomes a bit more of a checklist rather than sort of open question marks and things that we think through at pull request time. Here, if we can think through it like before you actually go and change anything, that should hopefully streamline some things.
Okay. Yeah, I think I see where you're going with that. Yeah.
Excellent. Doug, is there more detail on the GWB DC resistivity conversation that you want to have now, or should we sort of table that and have that in Google Docs and or follow-up conversations?
Yeah, I think the latter.
Okay.
That sounds fine.
Okay. Sounds good. Yeah, does anyone else have things that you'd like to bring up before we wrap things up?
I just want to make one comment, which isn't entirely SimPEG-ish, but definitely has tentacles. And that is that TKC is now front and center for a whole bunch of reasons. There's Thibault's been leading charge on a couple of papers that are getting close to being submitted. I've been asked to give a talk at Roundup in their forum talking about TKC, and this would be primarily to geologists. So it's an opportunity for us to kind of reinforce the potential benefits of doing advanced geophysical analysis, before they drill too much. And frankly, I was totally aghast when I realized that it was September 2015, 4 years ago, that we had the symposium that brought in all of these different groups of people, and we talked about what we'd been doing at TKC and the 3D inversion and the geophysical rock model and the classification. I just find it unfathomable to believe it was like that long ago. But anyway, yeah, so I think it's time to kind of build on that, and I'd like to just try to make sure everybody's involved, including Chris and Sarah, so that we can do a final synopsis of just putting everything together that we know, from a historical perspective and where we are from an inversion perspective. And then I do think there's probably still one paper to be written yet that incorporates more of the borehole information. So anyway, that's kind of front and center now for a couple of reasons. So I'll start a bit of a document, and people can add things that they remember, because it's some of it's just been, it was just like so long ago. I completely had forgotten about a few of these things, and then talking to Dom and Thibault yesterday, realized like, oh yeah, didn't we do something about that, estimating the volumes, and then went back and looked at the presentations, and sure enough, Soggy and had a 3D volume out there, and Dom with classifications, and yeah, so we don't want to forget things, and we just want to add some new stuff and really try to put together a really nice story.
And Doug, how do you envision capturing that? Is this like sort of a white paper in a sense, or is it a blog post, or is it going into GeoSci at some point? I mean, it's not necessarily something you need to answer now, but I don't know if you have an initial reaction as to.
Well, I think that I start off with maybe just some kind of a Google Doc in which we try to put down, okay, what were the geologic questions that was there, try to capture what the history was of the of the geology. Sarah and Chris did a pretty good job, and I mean, at one point I'd read all those papers and kind of had a pretty good idea, and that's just totally gone. I mean, I just can't remember any of this stuff. So it might be worthwhile to put a few of these things in a document and try to get a nice flow, and then people could interject on what they thought was important, and just try to piece together a story, and then we can see how to distribute it. Because, yeah, certainly something on GeoSci would probably be good, or on GeoSci, and yeah, I mean, it might give rise to another paper or something. But just to remember, capture, and put, because it is a really interesting example. And with all the drill hole information and the geology that was there, there is still stuff to be further developed, even though it's just a single deposit.
That sounds good. Any other last items? No? Okay. Well, happy American Thanksgiving to Saudi. And other than that.
We had our turkey yesterday.
Excellent.
Yesterday wasn't a holiday. Is that why tofu is so chubby?
Pardon me?
Is that why tofu is so chubby? He ate turkey?
Oh, there's a correlation.
Excellent.
Okay, well, to all our U.S. friends, have a good Thanksgiving.
Thank you. Take care, everyone. We'll see you next week.
Bye.
Okay, bye, guys.